Hello, Bunty. My God. Okay. Okay, Bunty, you're saying something? Okay, guys, today would be the final session. I want to make it interactive. Okay, so very good. Let me just, okay, wait a minute. Okay, so today is a live interaction. Uh, if you have any questions, you can ask me. Guys, can you hear me? My God. Okay. 2020 IIT Delhi paper. Question number 39. Okay. Okay. Before Bunty, so before I come to you, what about Swati? Can you hear me? Why are you silent? You don't, because today is an interaction. Okay. So if you have any questions, you can ask me, or any sessions or anything that you have bothering you for preparation of exams or not, you can, ask me. Right. And Aditya, Kushbu, Ashika. So of course, Ramesh, right? So you can let me know whatever the questions that are there. Okay. Okay, Bunty. Let me share my screen. Hmm. I think I have gate. Okay. Can you see my screen? Screen EC. 2020, na? What is it you're saying? 2020. Which question, Bunty? 39. Let me go to 39. Huh. Okay. So what is the bothering you here? Bunty, what you didn't understand from this? How to do this? Okay, do one thing. Let's do one thing. Okay. You know this, right? You know what is this actually? 1 by 0, what does it mean? Input and output, right? That means what? If you give 1, suppose let's say you are in the state 0. Okay. This is what they are saying, right? Sorry, sir. Something I messed it up. Hmm. So state 0 S0 is initial state, correct? If the output is 1, then, right? So if you are in state 0, if you get 0, that means that your output will be 0, correct? Hmm. Bunty, are you there or no? You open your mic, okay? Don't unmute it, okay? It's an interaction. So, uh, When there is a chance of you getting 1, where is output 1? You see this? This output is 0. Here the output is 0. Somewhere here you have a chance, right? Right? That means that you need to traverse this path. Like which path? S0, S1, S2, S3, S4, then S5, S3, right? Correct? One second. Somebody's want to join. Correct? So let's say if you receive 0, you write this path. Okay? 0, 1, 0, 1, 0. Over, no. Answer is there, right? Hey, Bunty. Answer is there, no? 0, 1, 0, 1, 0. Huh? Huh. 38. Okay, shall we give chance to someone else also? If they have any question, then I'll come back to you again. All right. Then who wants to ask me? Anyone else? Okay. Okay, Bunty. I think 30. Question number 38. Bunty, is it 38 you are asking? Okay. So PQR are the decimal integers corresponding to the 4-bit binary number 1100 considered in sign magnitude form, one's complement form, and two's complement representation. The 6-bit two's complement representation of PQR is dash. Okay. So guys, can you guys try this? It's not that difficult, but not that straightforward also. Okay, all of you try this and let me know what is the answer. Any answers? Aditya is saying option D. Bunty is saying option A. Okay, fine. So all of you understood the question, right? They're saying PQR are the decimal integers corresponding to the 4-bit binary number 11100 considered in sign magnitude form, one's complement form, and two's complement form. Okay. So what I told you first, let's get the decimal numbers. What exactly they? Let's say 1100 is considered in sign magnitude form. Okay, let me open my this thing. Okay, let's say I don't have pen tab. Sorry, I will be writing very badly on this right now. 1, 1, 0, 0. This is a sign magnitude form. This is, let's say, P, right? So the LSB bit, I mean, the MSB bit will be the sign. So this shows that this is a negative number. So what is the magnitude? For that, you need to find what are the last four bits magnitude is. 100, it is 4, right? So P is minus 4. Hmm? Similarly, let us say if this representation represents a ones complement form, that means 1, 1, 0, 0. Okay. Pardon me for my handwriting because this I am just trying to use my keyboard and then try to get it. Since this is a 1, obviously the number is going to be negative. How to find the magnitude? You do the two's complement, I mean one's complement on the same. One's complement if I do 0, 0, 1, 1, that is 3. Now similarly, what is the value of R? Can somebody put it in the chat box? What is this? Since the MSB is 1, so the R is negative. Can somebody tell me what is the R value in the chat box, please? No, you take 1100. Since the MSB is 1, I know that this is a negative number. How to find the magnitude? You need to find the two's complement of this number. So the one's complement will be 0, 0, 1, 1. Add 1 to this, right? Plus 1. So what is this? 0. 1 plus 1 is 1, 0. 1 plus 1 is again 1, 0. Again 1. Okay, this is also minus 4. Now what is that they're asking? The 6-bit 2's complement representation of P plus Q plus R. So what is the addition of P plus Q plus R? 8, 4 plus 4, 8, 11, right? Minus 11. Right. So if it is plus 11, what is the representation? And which representation they're talking about? 2's complement representation they want. Plus 11 is 1, 0, 1, 1, correct? So 6 bits that you want because that is 6-bit representation that you are talking about. What about minus 11? What about minus 11? You get the 2's complement. For that, find 1's complement. 1, 1, 0, 1, double, 0, add, plus 1. So 1, 1, 0, 1, 0, 1. So 1, 1, 0, 1, 0 is Aditya. That's what your answer is. 1, 1, 0, 1, 0, 0. Correct. Exactly. Hey, good Aditya and uh, Swati. Great. 1, 1, 0, 1, 0. Yeah. Swati, Bunty, you guys are right. Okay, Bunty, you already got the answer. Why did you ask me then? Ah, okay, fine. Any other question? अरे मेरे पास 22 नहीं है भाई. I think so. Hi. It is there. It is there. Okay, tell me. Which one? 31. Mhm. Mm. 18, 31. Yeah. The propagation delay of XOR gate and multiplexer in the circuit 4 nanosecond, 2 nanosecond, and 1 nanosecond respectively. If this we have discussed, no, sometime. It's okay. Anyways, you asked me. Okay. See, Bunty, what you need to do is, what is the path that you have? Okay, from okay, let me take the screenshot. Okay, let's come back here. Keep it. So you have a path from input to output, right? If all the inputs, right? These are PQRST. These are the inputs, right? And this is one path available to reach Y. The another path is either go through this or go through this. Are you clear now? So let's say you want to move from P to Y, correct? So what is required is on this path, right? Let me erase this. Let's say your interest is this path. That means that you have only two choices, right? Here, if you look at the t, either you can give t equal to 0 or you can give t equal to 1, right? So let's see what will happen for t equal to 0. Which is the network that gets involved in this? So if I choose t equal to 0, that means select line, this will be activated, this line will be activated, this line will be activated, right? Now for this line, the data depends on this gate, right? Doesn't really depend on this node, correct? So, but this is like AND gate, right? Even if you apply some inputs P, what is the delay of this AND gate? 2 nanosecond, right? This is just 2 nanosecond, right? And mux will take 1 nanosecond. That means that for t equal to 0, uh, if all the inputs are available at the same time, and if you make t equal to 0, the propagation delay from input to the output will be 3 nanoseconds. Are you with me, Benty, right now? Good. Can you calculate for t equal to 1 what will happen? Can you guys tell me? I mean, any of you can calculate and tell me what will happen. Do the same thing. When you make t equal to 1, so what is the path? So when equal to t equal to 1, then this one will be activated and this line will be activated. That means that you get the data from here to here till this point. Correct? Means the data at this node depends on AND gate, mux, and AND gate. Then from here it will go to Y, right? And you see how many elements are involved. Okay. To reach at this node, let's say A, this is the node A I'm saying. How much time does it take? Let's say you are applying some value at t equal to 0. Then AND gate takes 2 nanosecond, mux will take 1 nanosecond. Then again AND gate will take 2 nanoseconds, right? 2, uh, 2, 1 and 2. Correct. 5 nanosecond. Then for the data to reach output, okay, how much time the mux will take again? 1 nanosecond. So overall, these are the elements that are involved along this path, right? So two muxes and two AND gates. So AND gates will take 2, right? So 2, mux is 1, then this is 2, and this is 1. So overall, 6 nanoseconds it will take. Okay, then anyone else has any question? Yes, Aditya, you are right. Swati, you are also right. Yeah. So other people don't have any questions to ask? Okay. I'll do one thing. Can I ask some questions? Then say yes or no in chat box. Okay. So I think you can formulate this question. I can write wherever you want. Okay. So how many flip-flops are are the minimum number of flip-flops required to build a synchronous mod 1000 up counter? Synchronous mod 1000 up counter. Minimum number of flip-flops required to build a mod 1000 up counter. Also, asynchronous mod 1000 up counter when I say synchronous, yeah, mod 1000 ring counter, mod 1000 Johnson counter. Think about it. Yeah, I'm here. Asynchronous? No, boss. How it is 9? You tell me. What is the logic that you got? Huh? So 2 power n is how much? 2 power 9 is how much? So? Huh. 10 is correct. But what about ring counter? For Johnson, 500. Synchronous also how much? Exactly. Correct. Okay, anybody has any confusion? All these are right. Whatever he said is right. So synchronous 10, asynchronous 10, ring counter 1000, Johnson counter 500. Yes, Kushbu, you are correct. Uh, Swati, you are also right. Okay. So then that's one thing that I have. Please, Bunty, I'm waiting. Question number 46. 2020. 2021. Ah, 46. Okay. I think I didn't share the screen, huh? Oh, all right. Okay. Uh, you guys can see the screen, right? I think. Yes. Okay. The propagation delay of exclusive OR gate as a circuit is in the figure is 3 nanosecond. The propagation delay of each flip-flop is assumed to be 0. Very good. The clock frequency provided to the circuit is 500 megahertz. Assuming from the initial state value of the flip-flop outputs, starting from the initial value of the flip-flop outputs with D2 equal to 1, the minimum number of triggering clock edges after which this becomes 0, 0, 0. Okay. See, whenever, remember one thing, whenever this kind of timing issues are involved, better you go for timing diagram. Hmm? So when I say timing diagram, what I mean is this. So you draw a shit. Sorry. Whereas I'm really so sorry. I don't have pen tab today, so I have to struggle like this. You write the with respect to time what's happening. That's very very important. So the clock is there, right? Hmm. Now tell me one thing, whether it is positive edge triggering or negative edge triggered flip flops. What are these? Positive. Perfect. These are positive edge, right? So this is here, here. Can somebody tell me what is this actually? What is the time period of the clock? Hello. How do you know? 2 millisecond. Where, boss? Ah, so 500 megahertz. Then how it will be? 2 millisecond. हाँ कर लो 1/f करते करके 500 mega na, that is not 500 hertz, right? See this number. So 1 by 500 megahertz, how much will be? It is, I think, 2 nanosecond, right? 1 by, this is 2 nanosecond, right? Now here they are saying ki D2 value is 1, right? This is D2 value. Here it is 1. And they are saying, uh, the question says Q2, Q1, Q0 all are 111. Correct. So the minimum number of triggering clock edges after which the flip-flop outputs Q2, Q1 given as 0, 1, 0, 0. Okay, don't worry about when 1, 0, 0 will come. But first, let's worry about what happens after the first clock pulse. And they are also saying there is a 3 nanosecond. This is also very, very important, right? You see this? Right? The propagation delay of exclusive OR, XOR gate in the circuit shown in the figure is 3 nanosecond, right? Right? So ideally, tell me D2, you are this is the initial value starting, you have to assume something, right? Otherwise, you don't know where to start with, correct? That's the reason they gave. Here, D2 is 1, correct? Since Q2 is 1, D1 also is 1, right? D1 is also 1. Then, since Q1 is 1, D0 is also 1, right? 1, right? So, once you apply the clock pulse, right, during this time, correct, we know that Q2 becomes D2, Q1 becomes D1, Q0 becomes D0. Means this will be again 1, 1, 1. Okay. The leftmost will be Q1, sorry, Q2, the rightmost being Q0. Now, before you get into, let's say this is first clock cycle. Second clock pulse, what would have happened is, now Q2, I mean this Q1 and Q0 got a new values, let's say 1, 1. Now, I mean Q2, I mean this D2 is XOR of Q2 and Q0, correct? Right? Ideally, assuming that, let's say in ideal case, XOR gate doesn't have any delay, the moment Q2, Q0 becomes 1, 1, the D2 input will become 0. You guys agree, Bunty? But now what is the scenario? The practical case, it cannot become 0 immediately. It will become 0 after 3 nanosecond. That means Q2, Q0, they became 1, 1, right? When they became 1, 1? When they became 1, 1? Bunty, I'm asking you. No, no, no. I'm not talking about D2. I'm talking about Q2, Q0. When they became 1, 1? See, understand. The input D2, right? The input D2 is decided by Q2 and Q0, right? And Q2 and Q0 became 1, 1 at t equal to 0. Yes or no? Because the propagation delay of all the flip-flops is assumed to be 0. There is no propagation delay. The moment you become D2 equal to 1, Q2 will automatically become 1, right? When you apply the clock. Here, this is the instant I'm saying. This instant. This is the instant when Q2, Q1, Q0 all became 1, 1, right? Now, if you mark this as t equal to 0, let's say, let me mark that. Let me mark this as t equal to 0. Now, this is 2 nanosecond. Somewhere here, which is at 3 nanoseconds, or sorry, not that. Right? 3 nanoseconds will be somewhere here. Okay, I'm showing laser point. Okay, you can do it on your book. Okay, this is if it is 2, the total time period is 2 means half time period will be 1 nanosecond, right? Somewhere here, this one will be 3 nanoseconds. At this point, your D2 becomes 0. Are you guys with me so far? So far, so good. That means that when the clock comes at t equal to 2 nanoseconds, what is the value of D2? Yes, that means there is no change in the value of D2. Correct. See, here you see the only value that changes is D2. Otherwise, just D1 is replica of Q2, D0 is replica of Q1, right? Correct. Yes or no? Everything is 1, 1, 1. Until otherwise something fundamentally change here, nothing is going to change. Right? Are you guys with me? So, the value of D2 changes only. See, this is very simple because this is just a fundamentally shift register. Yes or no? Just a right shift register. Okay, the data will be moving out, but the data here is decided by the XR of Q2 and Q0. That's all, no, nothing else, right? Right. So the new data comes here after 3 nanoseconds. Till that time, you have to proceed with the same old data. Correct? So now here also it is going to be 1, 1, 1. But at this point, right? Let me change the color here. At this point, the T2 is going to be 0. What about D1 and D0? If D2 doesn't change, why the D1 and D0 will change? Correct now. Are you guys with me? Correct. So what I'm trying to say is at 3 nanoseconds, the data comes here, right? But the D1 value will be Q2 value. Are you getting it? D0 value will be previous Q1 value. Okay. That means D1 is still 1, D0 is still 1. You guys are okay with me or no? Right? So what I mean to say is fundamentally there is one, one that is stored inside. I would have drawn it in a beautiful way when I have a pen tab, but please try to understand this. I'm so sorry for it again and again. One, one is always stored in that. Now after the application of the clock, after 3 nanosecond, only this is going to change. Since it is a flip-flop, whatever the change that is happening here at the input of the flip-flop 2 or the flip-flop this D2 input doesn't affect this one. Are you getting it? So whatever is there at the output side of this flip-flop, whatever I'm pointing right now, will continue be there, or whatever is already stored in this will continue to be there. Are you getting it? Right? So now what you do, again you start the procedure, same procedure. Okay. So when you get the next flip-flop, you are going to get 0, 1, 1 at the Q2, Q1, Q0. Then check the next cycle, check the next cycle, check the next cycle. Like that, you have to repeatedly do it. Okay. So probably after some cycles, you will get 1, 0, 0 as Q2, Q1, Q0. So you have to do like this, cycle by cycle, you have to check. That's it. Very simple. Can you do that, Bunty, or somebody has done it already? Can you please let me know what is the answer in the chat box? Ramesh, have you done it? Okay, Ramesh, do it, do it. So as usual, if you have any questions or something, please mail it to me. I'll be responding to you as early as I can if I'm uh, not occupied with some other works or something. Okay, but definitely it may take 24 hours maximum. Before that, I will be responding to your questions or anything else that you need. Oh, is it? Okay, fine. This is the question. Oh, I'm not sharing the screen, right? Oh, sorry. This one. Can you see the question? Okay. Anyone else got the same answer? 6 clock pulses? Okay. I think you can try that. You will get it. Okay. So, any other questions? Okay. Swati, you got for 5. That's amazing. Okay, Ramesh, could you cross check, or Swati, can you cross check once again? Just mind you that you have to count from here, right? The starting. Ramesh, are you counting this one or no? Okay, so we'll move on. Anyways, you can cross check that. That's a thing. Okay. Any other questions that you have? If not, okay. So I wish you all the best, guys, and probably uh, you will do your exams very well. Okay, I'm sure about it. So if you don't have any questions, we can stop it right now and then catch up next time. I mean, maybe possibly next year. Okay. Yeah. Bye bye, guys. See you.